Welcome back, folks. Today we want to get into a little bit regarding math in chemistry and math and measurement, really. And we want to talk about something called significant figures. Good. And to start off our discussion, let's take a look at this. Consider the following figure. What value should you record? Well, the first thing to notice here is that we are talking about a measurement, right? This is some kind of measurement. And what we have to understand, well, two things we have to understand is, first of all, chemistry math is not math. For instance, in chemistry, 1.7 plus 1 is really not equal to 2.7. No, that's not correct. Yoink. 1.7 plus 1.7 plus 1 in chemistry is equal to 3. Why is that? Well, it gets back to this idea of measurement. In every measurement, there's some uncertainty. And we want to tell our reader, we want to give a signal to the reader of our numbers that there is uncertainty, and the way we do that is by using our significant figures. Okay, good. So here we have a measurement, and we want to impart to our reader that there's uncertainty here, and how do we do this? Okay, let's go back here to our notes. Significant figures. I like to break up significant figures into two ideas. We have when you're making them, so I would say creating sig figs. And the other is when someone else has already made them. And that would be then when you are analyzing sig figs. Analyzing or / calculating with sig figs. Okay, good. So we're over here, we're in the lab. So this is usually done in the lab. You have a reading and you need to figure out what to write down. And the rule is you write down all digits you are certain of. Well, let's write that. That's nice. Yoink! Sorry about that, folks. Let's erase that. All digits you are certain of. That's nice English. Yikes, sorry about that. Of which you are. All digits of which you are certain. Let's clean that up. Plus one estimated digit. Okay? So all digits of which you are certain and one estimated digit. Good. So let's go back to our picture here. What are we certain of? Let me erase this stuff over here on the side. Good. Okay, what are we certain of? Are we certain, first of all, are we certain that it's above 20? Here is my 20 line. Are we certain that it is a 2 and not a 3? So are we certain that it is 20 and certain that it's not 30? The answer is yes. We're certain that it is at least a 2. What else am I certain of? Well, this would be what? Here's 20. What's that line? That's 21. What's that line? That's 22. What's that line? 23. Good. Are we certain that it is 21 and not 22? Well, let's go back for a second and make sure we understand how to read a fluid, right? We have this thing here, and what do we call that on the fluid? That is called the meniscus. And when we read a meniscus, we want to read the bottom of the meniscus. So that means we want to read right about there. Good. Now, are we certain that right there is above 21 and below 22? Yes. So we're certain that we're at 21. Now, this line would be what? 21. This line here would be 21.5, right? Are we absolutely certain that that's 21.5? Yeah, to me, I'm not absolutely certain. That could be 21.5. That might be 21.6. I'm going to guess it's slightly above the 21.5, and I'm going to put 21.6. Good. Now, we have to remember that 6 is uncertain. You might look at that and say, oh, I think it's 21.5. Someone else might say, ooh, I think it's 21.4. But remember, this last digit that we write down it's estimated, and so there is some uncertainty, and different people will see it differently. I write down 21.6. Now, what does that mean? That means I am absolutely certain, and I'll bet with my life that it is at least 21, that the 20 is absolutely correct and the 1 is absolutely correct, and I'm just going to estimate that it's 0.6. Okay? So what's the value should I write down? I am going to write down 21.6, and we also need to write down what? Units, 21.6 milliliters. Okay, so that's the way we create sig figs in the lab. Let's move on now to analyzing sig figs. Okay, consider the following measurements. 254 centimeters, 0.00, that's nice, 0.00725 moles, 3,008.2 grams, 400 liters, and 400 point liters, and then 0.075700 kilopascals. How many significant figures are in each measurement? Okay, well, let us go back to our drawing, and let's add some more notes here. Analyzing and calculating. So let's break this down just into analyzing. Okay. Analyzing sig figs. Analyzing. Good. And what are the rules? Rules for analyzing. Okay, there are a group of rules. Number 1, all non-zeros are significant. So all non-zeros are significant. So we can go back to our consider and look at, we have, oops, go back to our consider, and what do we find? We've got a non-zero. That's line just doesn't work very well for me, does it? We have 3 non-zeros there. We have 3 non-zeros there. I have 1 and 2 non-zeros there. I have 1 non-zero, 1 non-zero, and 3 non-zeros. Okay, now in my first question, I have 254 centimeters. How many digits do I have? I have 3. How many non-zeros do I have? 3. How many sig figs do I have then? I have 3 sig figs. Okay, good. Now we have to add some more rules. Rule number 2, zeros, I'm just going to write it that way, before first non-zero are not significant. Okay? So, what does that mean? Zeros before the first non-zero. Let's go to red for this. Look at, I have 3 zeros. Let's look at this question, this one right here, right? I have 3 zeros before my non-zeros. So, and that's all the digits I have here, 0.00725 moles. I've got 3 non-zeros, and I have 3 zeros and I have 3 non-zeros. So how many sig figs do I have? These are not significant. These are significant. So I have 3 sig figs in that number. Now, moving over to the next question. I have 3008.2. Do I have any zeros before My first non-zero, do I have any zeros here? No, so that doesn't apply. Do I have any zeros before this 400? No. Do I have any zeros before this 400? No. Do I have any zeros before my 757? Yes, I do. I've got two non-zeros here. These guys are not significant. Okay, good. Let's learn some more rules. Rule number 3. No poofdas. No, that's not correct. Rule number 3. Oh, let's see. Zeros between non-zeros are significant. And I call this the field goal rule, right? Okay, by the way, let's write some examples here, like 217, 0.011. These are not significant. Field goal rule, 207. Good. See that 0? It's going between the uprights. That means that 0 is what? Good. 3 points. Good. So let's try out to apply that. Let's go to our question. Here, do I have any zeros between non-zeros? Okay, here's a non-zero. And here's a couple of non-zeros, and here's two zeros in between. That means those guys are what? Good. So I have 3008.2. I have a non-zero good. I have an 8 and a 2 good, and the two zeros between my non-zeros are good. So how many total sig figs do I have? 1, 2, 3, 4, 5. I have 5 sig figs in that question. Good. Next. Ooh, this one's a tough one, I think. Rule number 4. Let's extend the page. Rule number 4. I'm going to state it this way. In a number without a decimal point, zeros to the right of last non-zero are, and I have to be careful here because some people say this differently, are usually not significant. So in a number like 100, what's my, first of all, 100, there's no decimal, right? My last non-zero is 1, and where are my zeros to the right of that? These guys are to the right of my last non-zero, so that means they are not significant because there's no decimal. So how many sig figs do I have here? I have a 1 sig fig. So go look at our question. Right here, I have 400, right? No decimal. My last non-zero is the 4. That means my zeros to the right of the 4 are what? Not significant. So in a number like 400, without a decimal, I only have 1 sig fig. Good, but what about if there is a decimal? Aha, you guys are catching on here. Good. So let's add another rule. 5 in a number with a decimal point, zeros to right of last non-zero are significant. Got it? Okay. Example would be what? 200 point. I have to add another one, 200.0. Good. I have a decimal, yoink. I have my last number. How many zeros are to the right of my last number? 1, 2, 3. That means this is significant, that's significant, that's significant, and that's significant, meaning I have how many total? 4 significant figures. So in our 400, I have a decimal. I have 2 zeros to the right of my last non-zero, meaning I have 3 sigs. So in 400 point, I have 3 sig figs. Now think about this for a second. What is the message I'm trying to send? Why would I waste all my time and energy and ink writing a decimal unless I'm sending a message to my reader? Up here, no decimal, meaning what? I'm certain of that number? Excuse me, I'm not even certain of that. I am estimating that number. That's an estimate. That means really my number can be 300, can be 400, can be 500, could even be 600 because that 4 is estimated. What message am I sending here? Well, I have 3 sig figs. That means these two are certain. This last 0 is uncertain. It's an estimate. That's a question mark there. So really what I'm saying to the reader is this could be 400, could be 401, could be 409, but what can it not be? I say I'm certain that it's a 40, so it cannot be 410. There's no way that that measurement can be 410 because I said I have 3 sig figs. Got it? That's why this decimal here is an important indicator to us. Okay, the last one here. We still have what? No, I think we can answer this, right? We have zeros at the beginning of a number. We have zeros at the beginning. They are not significant. We have non-zeros. They are significant. I have a decimal point. Oops, sorry. I have a decimal point. That's nice. Yoink. I have a decimal point right here. Oh, there we go. And to the right of my last non-zeros, I have some zeros. That means those non-zeros are significant. So that means something like 0.075700 has what? Not significant, significant, significant. 5 sig figs. Whoo! That could be a little confusing. Just go back and check the notes that I gave you. Are you ready? Here we go. You're on your own. Hit it. Consider the following measurements. I have 12.540 meters, 0.08206 liter atmospheres per gram Kelvin. Gram Kelvin, that should be mole Kelvin, sorry. And 1,250 centimeters cubed. While you work on that, I'll change my units here to the right units. Go. So that needs to get rid of that. Okay, you ready to give this a shot? Let's give it a shot. Here we go. We have 12.540 meters, right? First thing we know is what? All non-zeros are significant. What can we say about this 0? Well, I have a decimal, and my 0 is to the right of my last non-zero. That means that 0 is what? It is significant. So that means I have 1, 2, 3, 4, 5. I have 5 sig figs. Good. Next one, 0.08206 liter atmospheres per mole Kelvin. I have to get those units right. Well, and let's start analyzing this. I have 2 zeros before my first non-zero. Those are what? Not significant. I have 3 non-zeros, and then I have a 0 between 2 non-zeros, and that is what? Good. So that means I have 1, 2, 3, 4 sig figs. Great. And finally, I have 1250 centimeters cubed. By the way, a centimeter cubed is equal to what? Well, a centimeter cubed is exactly the same as a milliliter, and that conversion will be helpful to you throughout the year. So remember, 1 centimeter cubed equals 1 milliliter. Great. Now let's analyze this. I have 3 non-zeros, so those are significant. I have a 0, but look it, no decimal, no decimal. So what happens if I have a 0 to the right of non-zeros, my last non-zero, and there's no decimal? That means that 0 is what? Not significant. So in 1250, I have 3 sig figs. Okay, good. By the way, remember that rule is usually, some people would say that that 0 is significant, but for our purposes in this class, unless there's a decimal, we're going to say that 0 is not significant. Okay? Great. Well, if we go back and look at what we've covered, we started off with sig figs, and we talked about creating sig figs in the lab. We said that you're going to do some analyzing and calculating. We talked about analyzing, meaning what's left. Well, that means there is calculating we need to talk about. So let me extend the page, and we're going to bring down our line from calculating. Here we go. Are you ready? Extend the page. Extend the page. Extend the page. Oh, that's pretty. Here we go. Yoink, 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 yoink. And we're coming down. And what are we going to talk about? Calculating with sig figs. Good. And we're going to need to extend the page. And there's 2 types of calculations we are going to do. Let's draw a little circle here. Let's come over this way and say, we'll do the easy one first. Multiplying and dividing. And over here, let's talk about adding and subtracting. Okay, multiplying and dividing is easy. And here's the rule. My answer has same number of sig figs as operand. That means the numbers I am dividing or multiplying as operand with the fewest number of sig figs. Good. So what do I mean by that? Let's say I have 1,100.172, and I'm going to multiply that by 2, right? And the question is, how many sig figs are in my answer? Well, how many sig figs do I have in my first operand? 1, 2, 3, 4, 5, 6, 7. I have 7 sigs. How many do I have in my second operand? I have 1 sig. Okay, what does this say? My answer has the same number of sig figs as the operand with the fewest. 7 versus 1, which is the fewest? 1. So how many sig figs can I have in my answer? I can only have 1 sig fig in my answer, meaning what do I have to do? I must round. So let's take 2 times this. I think we can do this without a calculator. 2 times 2 is 4. 2 times 7 is 14, carry your 1. 2 times 2 is 2 plus 1 is 3.2002. Good. But I can only have 1 sig fig. So it means I can only have my 2 here. That means I have to round 2002.344, and I have to round it up either to the next highest thousandths, to 3,000, or I have to round it down to the next lowest thousandths, which is 2,000. Which is that closer to? 2002.344 is closer to what? 2,000. I have 1 sig fig, so my answer now is 2,000. When I take 2 times 1,000, 1.172, I get 2,000. Okay? Now, just a rule of thumb, when we are rounding, for rounding, I'll write rounding here, right? Rounding. If the number I'm rounding is 5, we will round up to the next higher. If my number is 4, we round down. So let's say I have 2500, and I have to round that to 1 sig fig. We would round that up, and we'd round it to 3,000. If I had 2400 and I'm rounding that, I round that down. Oops, that's not rounding down. I round that down to 2,000 for 1 sig fig. Got it? Okay, great. Let's erase that so we have more space to talk about adding and subtracting. Adding, subtracting, what's the rule? Okay, let's hope I can get this right. The answer can be no more precise than the least precise operand. Wow, does that help us any? Well, if you know what precise means, it does. In this case, precise means number of decimal places. Okay, so then, can we write this in a more useful way? I think we can. The answer has same number of decimal places as operand, the things we are adding or subtracting, operand. I hope I'm spelling operand right. It's a T instead of a D. Operand, places as operand with fewest number of decimal places. Cool. What does that mean? Okay, so I have 2.4 and I have 18.72. What to add those? Now here's the way I like to do this. I want to line up my decimal points, and then I line up my decimal places, and I'm going to draw a line to the right of the one with the fewest. Now I add 2, 11, carry the 1, 10, 11, carry the 1, 21.12. Good. Notice I have this 2 floating out to the right of this line. What does that mean? That means that number is not significant. So what is my answer? My answer, when I add 2.4 to 18.72, my answer is 21.1 because I can only have what? My 4 is in the tenths column. My 2 is in the hundredths column. Which of these is least precise? Tenths is least precise, meaning my answer can only have a decimal in its smallest decimal can only be to the tenths. Got it? Good. Let's see if you can do this on your own. Okay. Well, no, I'll do this with you. Sorry. We have 17.34 grams, and I'm dividing that by 230 milliliters. What's my answer? Okay, 17.34 grams. Divide that by 230 milliliters. I use my calculator. Good, my calculator says 17.34. Divide that by 230, and I get, how about 0.07539 Good. Now we have to figure out how many sig figs. How many sig figs do I have here? I have 4. How many sig figs do I have here? Well, notice no decimal. It means this 0 is not significant because it's to the right. I have 2 sig figs. So I have 4 sig figs divided by 2 sig figs. How many sig figs can I have in my answer? The answer is 2 sigs. So how do I make this into 2 sigs? I have to round it, and I'm going to round it starting. I have to round this 3, right? Is that higher than 5 or lower than 5? Well, that 3 is lower than 5, so that means my answer is 0.07, and I round down. 5 is where we stop. And then I have to look at my units. Grams per milliliter. Grams per milliliter. Hey, what else is grams per milliliter? Hey, this looks like what? It looks like a density measurement. That's exactly what it is. So my answer is 0.075 grams per milliliter. Now we'll let you do one. Here you go. Give you a couple seconds. Go. Okay, here we go. We've got 8.314 joules per mole Kelvin times 334. And this is a multiplication, so that means I have 4 sig figs times 3 sig figs. How many sig figs can I have in my answer? Well, when I have multiplying or dividing, my answer has the same number as the least number. I have 3 sig figs, so that means my answer can only have 3 sig figs. So let's take 8.314 times 334, and I get a big number. How about 2776.876? And I have to round that to 3 sig figs. That means I want to round it right here. So I have 2776. Is that closer to 2780 or 2770? Do I round up with the 6 or down with the 6? Well, 6 is closer than 2780. It's above 5. I round up. So my answer is 2780. What are my units? I have joules per mole Kelvin times Kelvin. That means my Kelvins cancel. And I have joules per mole. So 2,780 joules per mole is the answer. Next. Aha. Here we go. Consider mixing 25.27 milliliters of water with 77 milliliters of water. What's my total amount? I'll help you with this one. We have 25.27. To that, I'm adding 77. Add that. Good. This is addition. This means I want to line up my decimals, right? And add. So I have 7, 2, 12, 1, 0 point. It's where my point is, right? Here's my point. Good. Which one is least significant? Right here. Not least significant, least precise. Over here, I'm precise to the hundredths. Here, I'm precise to the units. Good, which means my answer can only be precise where? My answer can only be precise to the units. So I take 102.27. I have to round the 0.27, the 0.2. It's 0.2 higher or lower than 5. It's lower than 5. So this rounds down to 102 milliliters. There we go. All right, the last slide of sig figs. It's up to you. Here you go. A beaker containing 125 milliliters of silver nitrate solution. After pouring 72.5 milliliters from the beaker into a Erlenmeyer flask, how much silver nitrate solution remains? Go! Okay, I have 100. Sometimes it's best to draw a picture, right? So I have a beaker, and I have 125 milliliters in that, and I'm going to pour some of that out into an Erlenmeyer flask, right? And specifically, how much do I pour? I end up pouring 72.5 milliliters, so that means my volume in here drops down, right? And we want to know what's my new volume in my beaker. So what kind of question is this? It's a subtraction question. I have 125 milliliters. After pouring 72.5 milliliters out, let's move my milliliters here so we can line this up. Subtract, how much do I have left? I'm going to draw my line. Remember, that's where my decimal point is. So let's put my decimal point here. Okay, that has to become 4, 10, 5, 2, 5, right? 52.5. I look to my dotted line. This 5 is hanging there. That means I have to get rid of it. Does it round up or down? 52, I have 52.5. 52.5 does what? Rounds up. So that means I have to take 52.5 and round it to 53. Units are milliliters. So my answer is 53. Okay, good. That is significant figures. I expect you to use significant figures in everything. Uh, I will grade them on all your labs. So every time you record numbers in the lab, you need to use sig figs. Every time you do calculations for the lab, you need to make sure you're following these rules and use the sig figs. Okay, cool. See you next time.